In this video, I am going to explain about magnetism in electrical engineering and certain terms related with this magnetism with important equations. So, we will be seeing magnetic field around a bar magnet first. In this picture, you can see a bar magnet with the north and south pole. Here, how can you feel the influence of a magnet? The influence of a magnet is felt by the space around it, and this region of influence is usually referred to as field of the magnet. Whether this is visible to us? No, the magnetic influence is invisible and it can only be represented by certain lines. Such lines are known as lines of force. You can see here the lines of force originating from north pole, leaving the north pole and will be entering the south pole. If it is extended to this bar magnet also, then these lines are known as lines of magnetization. So, these lines of force and lines of magnetization will form a closed lines. That is, it will be a closed path. Such lines are known as lines of induction. So, here you will be knowing that magnetic field of the magnet means influence of the magnet. Then lines of force means the influence of the magnet is invisible to us and is represented by certain lines, and those lines are known as lines of force. And when it is extended to magnet also, then it is known as lines of magnetization, and these lines of force and lines of magnetization forms a closed lines, and these lines are known as lines of induction. Then magnetic field around a current carrying conductor. So you know that when an electric current is passed through a conductor, magnetic field is set up in the surrounding space all along the length of the conductor. So, this magnetic field forms concentric circles or planes normal to the direction of current. Then, the relation between this direction of magnetic field and current in the conductor can be determined by Fleming's right-hand rule. So, state Fleming's right-hand rule. Fleming's right-hand rule states that if the current carrying conductor is grasped by the right hand, so that this thumb will be points in the direction of current flow, then these fingers will be points in the direction of lines of flux, or vice versa. So, thumb will be pointing in the direction of current and then the fingers will be pointing in the direction of the lines of flux. It is explained by Fleming's right-hand rule. So, you know that when this plane of the coil is perpendicular to the flux direction, then maximum flux will be flowing through the coil. That maximum flux phi can be denoted as BA. When plane of the coil is parallel to the flux direction, no flux will be passing through this coil. This is the minimum flux direction. When it is inclined at an angle theta, you can represent phi as BA sin theta. This all you will be knowing in your 12th standard or previous classes. So, we will be seeing certain terms related to this magnetism in this video. First term is magnetic flux phi. Then what is meant by this magnetic flux? Magnetic lines of force produced by a magnet is called as magnetic flux. It is usually denoted by the letter phi. Then that is, we can call it as amount of magnetic field. Magnetic flux means amount of magnetic field quantitatively. Then its unit is usually represented by Weber. Then these characteristics are, these flux lines will never intersect. These flux lines do not have any physical existence. Each line of magnetic flux is a closed loop by itself. Then the lines of magnetic flux closer to each other and having opposite directions attract each other and lines of magnetic flux closer to each other and having same directions repel each other. Direction is defined as the direction in which an isolated north pole would if it were placed in a magnetic field. We already have seen in my previous slide. Then next term is magnetic flux density. Magnetic flux density means, from this term itself you will be knowing, flux density means flux per unit area. Here flux density is usually denoted by the letter B. You have to know all these representations, then only you will be able to solve problems. So magnetic flux density usually represented by the letter capital B. Flux density means flux per unit area at right angles to the flux. Then you can see here phi means Weber and A means area. Area unit is meter square. So here magnetic flux density having the unit Weber per meter square, or it can be simply represented as Tesla. The next term is magnetomotive force. You know, in electric circuit, equivalent to magnetomotive force is EMF. Same here, MMF means it is the cause producing flux in a magnetic circuit. MMF means it is the cause producing flux in a magnetic circuit. That MMF can be represented by NI. N means number of turns and I means current flowing through the conductor. So number of turns can be represented, that is its unit is T, and I means current, so unit is A, ampere. So MMF having the unit ampere turns. MMF having the unit AT, AT means ampere turns. MMF means it is the cause producing flux in a magnetic circuit. Then next is magnetic field intensity or magnetizing force represented by the letter capital H. Magnetic field intensity or magnetization force means MMF per unit length of the magnetic flux path, which is represented as MMF means Ni. Per unit length means divided by L. So it will be having the unit ampere turns, length is having the unit meter, so ampere turn per meter. H is equal to Ni by L, which is equal to ampere turn per meter. Or it can be represented simply as MMF by length. So Ni means MMF, so it can be represented as H is equal to MMF by length. So ampere turns per meter. Then next is permeability. Permeability means is conductivity. That is the property of a magnetic medium. Here permeability usually represented by mu. As you all know, B is proportional to H. Then what is meant by B? B means magnetic flux density and H means magnetization force. This flux density is directly proportional to this magnetization force H. So you can remove this proportionality by means of a constant which is known as permeability. So B is equal to mu into H, where mu is known as the constant of proportionality which is called as permeability. So permeability means permeability of a material means is conductivity. So mu is equal to B divided by H. Then relative permeability. What do you mean by relative permeability? Relative permeability of a medium or material is defined as the ratio of the flux density in that medium or material to the flux density produced in vacuum by the same magnetizing force. So mu r can be represented as flux density in the medium divided by flux density in vacuum. Here mu r is equal to mu divided by mu 0. That is mu is equal to mu r into mu 0. Mu means permeability, mu r means relative permeability, and mu 0 means permeability of vacuum or free space. That is absolute permeability. Mu 0 means permeability of vacuum or free space, which is having the value 4 pi into 10 raised to minus 7 Henry per meter. Absolute permeability mu 0 of vacuum or free space having the value 4 pi into 10 raised to minus 7 Henry per meter. Then relative permeability of this vacuum or free space, that is mu r of free space or vacuum is equal to unity. Mu r of air is also nearly equal to unity. Mu r of vacuum or free space is also unity. Then next term is reluctance. Reluctance means it is the property of magnetic circuit by which the setting up of flux is opposed. That is opposition that the magnetic circuit offers to magnetic flux. Opposition that the magnetic circuit offers to magnetic flux is known as reluctance. Reluctance usually represented by this letter S. So S is equal to mmf divided by flux. You know that mmf means N into I. So mmf Ni divided by flux phi, that is Ni by phi. So it will be having the unit Ni means ampere turns and phi means Weber. So reluctance is having the unit ampere turns per Weber. This reluctance also can be represented in terms of its permeability by S is equal to L divided by A mu. Here mu can be replaced by mu 0 mu r. So S will be having also the equation as L divided by A mu 0 mu r. Then permeance. Permeance means it is the reciprocal of reluctance. What do we mean by permeance? Permeance means it is the readiness with which magnetic flux is developed. That is, it is analogous to conductance in an electric circuit. Its unit is permeance means 1 by reluctance. So its unit is Weber per ampere turns. Weber per ampere turns. Next is comparison of electric and magnetic circuit. We have already seen certain terms related with the magnetic circuit, and these terms are compared with the certain electric circuit terms. So, closed path for electric current is called as electric circuit, whereas closed path for magnetic flux is known as magnetic circuit. In electric circuit, we have got current. Current equation is V by R. I is equal to V by R. That is EMF by resistance. Similarly, instead of current, in magnetic circuit, we have got flux. Flux equation is mmf by reluctance. So EMF is equivalent to mmf and resistance is equivalent to reluctance. Resistivity is equivalent to reluctivity. Conductance is equivalent to permeance. Conductance means 1 by resistance and permeance means 1 by reluctance. Current density means current per unit area, which is equivalent to flux density, which is flux per unit area. Current density denoted by letter J and flux density denoted by letter B. Electric field intensity E means it is the measure of force exerted by one charged body on another. It is represented by electric field intensity is equal to F by Q. It is expressed in terms of Newton Coulomb inverse or volt per meter. That is V by D, which is equal to volt meter inverse. Similar to electric field intensity, we have magnetizing force H. Magnetizing force H is equal to mmf per unit length. Hope you have understood this video. Please subscribe my channel, like my video and share it with your friends. Thank you.